What's up everyone, welcome back to the channel. I'm Logan with 89 Auto Works, and today we are diving back into your guys' favorite build around here. We are diving into the Rocketwagon, Jons 2002 Subaru WRX that we have absolutely turned into a street monster. We started this car in terms of build goals in making the perfect daily driver. Biggest problem we ran into with this car was we did not stay on a oil change schedule, and basically I caught the motor right before it was dying. So I'm going to do my best to make 3 videos into one. I kind of wanted to show you guys when we got the car in for the first time. It was just here for a fuel system upgrade. Day before we were going to the dyno, we discovered that the oil had not been changed since the following year when I gave him the car. And unfortunately, you know, to have toys like this, you have to work like this, and that means you don't have a lot of time. So these things do happen, unfortunately. While we had everything out, we decided it was in our best interest to go ahead and buy a built short block from one of our good suppliers, which is Outfront Motorsports. This is what this motor is. This is an Outfront V3 long rod motor. So this is EJ257 closed deck case halves, and this is JE FSR pistons that have been shortened specifically for the long rod application. It has Outfront long rod H-beam connecting rods with 625 ARP bolts and a 2017 plus STI crank. This is a nice setup here to run some seriously good RPMs. G4X plug and play standalone setup for this car. This is absolutely the setup to go with. We are running this setup on Subaru, and I will tell you, from the time we got the link fully programmed and working to the time it went to the dyno, it absolutely was a breeze in terms of the car liking the setup and liking everything that I was getting. So we went ahead and got one for the Rocketwagon as well. Being as this is an 02 WRX, this is a pretty outdated setup, and for those of you that don't know, this is obviously a hybrid setup motor. Being as this motor is a hybrid setup, we thought it was going to be best for especially the knock control to go to a standalone ECU setup where we can dial in our knock control far past what the stock setup can. Now, the 02 WRX ECU was running an advanced ROM. We were running Carberry on it, for those of you that know what that is. And that was how we got by with our speed density and everything to be able to run our hybrid setup. So now we are going to be going to this link setup, which is really great. And the one addition to that we have been running is this CAN lambda sensor, and it works really great. So for our heads for this motor, being as it is a hybrid motor, these are H20B heads. The only difference now that we're going to be doing that we did not have before is we are running a JE Pro Seal head gasket set, which is absolutely the way to go, and especially with the horsepower level we're going to, definitely something that is going to be beneficial. The only other thing we are changing on the car is this is going to be our time when we can install our Grimmspeed unequal length header. This is a hybrid unequal length header. We are really looking forward to seeing how this is going to go. And this was a replacement for a Killer Bee Holy header, so we're looking forward to seeing what kind of horsepower this thing will make. Drop down below, what do you guys think this thing is going to make on the dyno? At the end of this video, I want to know what you guys think this thing's going to make on pump 91 cranked up. Go ahead and drop that below in the comments. We are going to start diving into putting this motor together, and right now I'm going to put you guys back and show you guys some of the stuff we did beforehand, some of the teardown points on the motor to show you guys the failures and where they were taking place, and I will show you guys basically what led us up to this point, and then we are going to dive into putting this thing together. We got the Rocketwagon motor pulled. Didn't take us too long, but we have it on the stand now. So this is the motor. Once we get into the valve covers and the oil pan, we'll start talking about the things we're going to be seeing, because I'm certain that when we get into the oil pan, we're going to be seeing a lot of flakes and different things like that going on of bearing material. That's what I'm suspecting. I have no actual information that's telling me that, other than an oil analysis that said that was one of 4 different things that were making metal. So I'm thinking that the bearings are the actual problem, and that's what we're going to find out. So I'm going to go ahead and rip this intake manifold off, and we will see where that leads us. So if it wasn't clear by this point, I am having an absolutely terrible day. I had to tear apart a customer car due to some negligence, and here is how I am rewarded by this fun moment. God damn it. I definitely just got stung by a wasp on the side of the head, and I got it on camera. Wow. Ugh. I can't make this shit up. God damn it. God damn it. So you guys can see the amount of sludge that is in this oil pan. Definitely a good amount of metal and sludge that's left in here from the E85. And this is the type of things that you have issues with when you have contaminants left in your oil from E85. So as you guys can see here, here's cylinder 1 through 4. This is number 1. You can see the excessive damage to each one of these bearings. And that is due to the fact that the viscosity of the oil had been reduced so significantly with the E85 being left in the oil. And what that does is not only leaves E85 particulates in the oil, it also introduces moisture into the oil, which is going to absolutely wipe out anything on the internals of your motor. The main bearings definitely looked better, but they certainly were not in any sort of good shape, and that is exactly why we went ahead and tore this motor down. If you look at the actual cylinder walls, the cylinder walls looked okay, but you can see the discoloration, and that is due to the E85. Alright guys, so we are back at it today, working on the Rocketwagon, and some time has gone by. We've been waiting on some stuff to come in for the Rocketwagon so we could finish up what we were working on. As you can see, we got the motor installed. We are about 95% complete on the motor install. Everything is in. We set up everything on the motor like we always do. Went ahead and lashed everything out. And at this point, the only thing that's missing pretty much is the front mount piping for this thing to run. Before we did that, I wanted to dive into the standalone install. So this video is going to primarily be about the Link G4X standalone install. I absolutely cannot tell you guys how much I absolutely love their products. Subaru was the first car we ended up putting one of these in. Absolutely night and day difference for tuning, for startup, for everything. I absolutely love the Link G4X product, and it will be something I'll be using a lot going forward. So the Link setup we are going to be putting in the car, basically this is everything that we will need to get the Link installed in the car. So we went ahead and yanked the factory ECU out of the car because we will need to pull the board out of this and use the case for our ECU install. So obviously we have our actual Link G4X plug and play standalone ECU. And then some of the other things that we have that are not necessarily needed, but definitely add to the reliability. And I did just have a nice long conversation with my tuner up at Nemtech Racing. And we definitely had a long conversation about why the CAN lambda sensor that Link themselves sells is superior to the AEM Series X Yugo that we do have on the car. Being as this is CAN enabled, this is a faster reporting, and it does have some nice things built in for the startup and for the actual warm-up cycle of the actual sensor itself. So we are going to put this in, and we are also going to keep our AEM setup in place. So we did add a second bung in the bell mouth of the downpipe to be able to run both of these. So now, if you are running the CAN lambda sensor, you will need to buy the CAN connection wire, and basically this will plug into the CAN 1 port on the standalone and allow you to wire in your gauge directly. Now, there is some things that we are going to need to do to run this setup. Primarily, we are going to have to install a relay in place that's going to run directly from the battery to power the sensor. This is going to be something we will hook up to an ignition source on the car and basically make it so when the key is on, the sensor has power from the battery directly to make sure we are getting a good reading. Now, one of the other main things that we are going to be doing with this setup is using the ECU to wire in all of our gauges that we do not have access to in the stock ECU. Primarily, we are going to be looking at ethanol content. Primarily, we will be looking at fuel pressure. Primarily, we will be looking at oil pressure. The big factor here for us to be utilizing the inputs on this ECU is so you can incorporate safeguards into the whole process of the tune. So if the car were to see below X oil pressure, it would put it into limp mode or turn it off. And if there were to be the same situation for fuel pressure, we were to see a fuel pressure spike, of a drop, you know, something especially along the lines of while we are under boost, the car will kill the boost and make it so it will not kill the car. So one of the things we had to purchase for this to work is this is an AEM 150 PSI brass sending unit. And the biggest difference between the brass and the stainless sending units, according to what I have recently been told by my tuner, is the brass sending units are more of a reference setup, and the stainless sending units are more for actually running different things. For example, on this car, we do have the AEM map sensor, and that is a stainless map sensor. Because the car is calibrated and ran off of that map sensor, we would not use a brass sensor. Now, because this sensor is going to be routed in line and will be used as a reference for the ECU to know if there is a problem, and it is not necessary for it to run, a brass sensor is everything we will need there. So I have never ever set up an ECU with inputs this way. I did set up Jake's with some inputs in the can stream, and I've never set them up with the external expansion harness. So this is Link's XS plug-in expansion loom, and basically it gives you a nice loom that comes with several feet of wire, and this is what you would use to hook up all of your gauge inputs. And there is a wiring diagram online that we will pull up specifically for this process. So I hope you can see well. We are going to dive into opening this up just so I can give you guys a nice look at what this does look like inside of here when you pull these open. So we'll go ahead and remove the case screws themselves. Be 5 case screws in total. We'll go ahead and open these up. Here is our stock 16-bit ECU. As you can see, there's lots of little things going on here that definitely require a lot more knowledge than I have in this regard. So we'll go ahead and pull this out. Obviously not something we will probably ever be using again, but we will take special care to make sure this does not get trashed. So now you guys have seen what the inside of the case looks like. Pretty simple stuff. We will go ahead and open up our Link ECU. So again, huge shout out to Outfront on this one. They definitely hooked us up. Here is our actual Link ECU board. It is definitely taken care of to be wrapped in anti-static, you know, whatever you want to call it, packaging here. If you go ahead and open up this little area, there is a USB cable and your wrist strap. And then we obviously got some sweet Link stickers. What Link does not tell you is to make horsepower, you have to install one of these stickers right off the bat and go, money. See, now this is actually go fast parts. And if you wanted to go really fast, you'd put another one on here, and you can just keep doing that. Stack these, you get roughly 5 to 10 horsepower a piece. So if you put like 10 or 20 stickers on here, you might have some serious notable power gains. So here is our actual manual here. Read this if you haven't read it before. And then obviously we are just looking at some different settings in here. Now it's extremely important, depending on what vehicle you have, you make sure that you read this first couple sections without a doubt, because there is some different things. Mainly There is some switches that you have to make sure are flipped in one direction or the other, and that is for immobilizers. Obviously, this car being a 2002 WRX, it does not have immobilizers. If you guys don't know what that is, basically anything 2005 plus or STIs 2005 plus is going to have an immobilizer, meaning that the key, transponder, and the immobilizer all have to match each other, and the ECU all have to match each other for the car to function properly. So I'm going to glance through this real quick, make sure we have everything set in the right direction, which it should be, and then we will talk some more about that. So pretty tragic news, because this is definitely going to screw with everything we have going on here. There was an error somewhere along the line, and we were sent the wrong ECU. This is for a version 5 to version 6. We will still carry forward and work on getting everything else happy until that point, and pretend just like we absolutely have nothing we have to worry about, and we can just party on, Wayne, all the days of the future of my life, even though that's not going to happen. But here's where we're at. This is the point we're at, and looks like we'll be waiting for some parts. For now, we will look at getting our CAN lambda sensor ran and actually set up in place so it will be ready to plug in. Same thing goes with all of our wiring for our relay and our power and fuses and fuel pressure sensor and all the good stuff. We will continue forward. Jeremy's going to get us taken care of once again and get us the right ECU over here right away. I love it. I love it. Yep. Damn it. You know what the worst thing ever is I just realized I got too excited. To do this style connector right here, the wire has to be slid down through the top. Going ahead and jumping forward to setting up for our CAN lambda sensor. Basically, the main components are our adapter here that plugs into our ECU for our high-low CAN signal, and then we will need obviously our CAN lambda adapter, and then the sensor is in the car, and then we will need our relay and wiring for it. Basically, how this is going to work is this is going to plug into our wideband O2 sensor, our CAN lambda sensor, and then this is going to plug directly into here. These are DTM4 connectors. So then basically this will plug into the ECU, bloop, plug that in, and then we have these two wires here. Now obviously red is hot, black is ground, and that's going to correspond to our red and black on here. Now it is important to note that this is going to go to here, red to black, but it's also going to be, I'm sorry, so it's going to go black to yellow here, and then we're also going to need to run one directly to actual ground in the car. So basically then we will need to be working on wiring our triggering and everything else. This is all going to be stuff that we are going to want to for sure solder and, you know, make sure there's a happy, very happy connection there. So with this, we're going to go ahead and basically take this, our hot off of here, which is our actual triggered hot, and we will wire that in directly to here. And this will allow us to have proper power to this that is switched, and it will allow it to work when it's, you know, supposed to. Basically, we have this thing set up, all twisted up, ground and everything, so we have no interference for our power, for our relay, and our power for our CAN lambda. So we are going to go ahead and start working on getting this into the car. We still don't have the standalone, so basically at this point we're just going to be running this in place of where we would be putting it. We will run our power to the engine bay, and we will run our trigger up to the radio area and find ourselves a nice trigger for the ECU to kick this on with. So we're going to go jump into the car. Not sure how much I'll be able to show you in the car, but I'm going to do my best. All right, so here's kind of a look at what we have going on in here. Our ECU is just sitting in place. You guys can see our ECU is just sitting in place. This is our expansion loom that we will use to make our inputs. And then we have our ground set up for our relay. So our relay is in here. Basically, this is going to be giving us switched power to our CAN lambda sensor. And then the only thing we will have to do for that is take our CAN lambda module and actually plug it in sideband coming off of the downpipe. The other thing we have ran through is we have our wire that is going to our AEM fuel pressure sensor that is directly on the fuel pressure regulator. We have our 3 wires coming through. One is going to be 5 volt in, one's going to be 5 volt out, and one's going to be a ground. And these will get wired into our expansion loom. This is the part of the install that I wanted to kind of talk to you guys about that is really hard to show. But I went ahead and made a little graph here so you guys can kind of see what we have going on. So on the actual inputs on the ECU, it is ground 5 volt positive, aux 9, aux 10, volt 6, 7, 9, and 10. So basically what you guys need to know is this is a sensor ground. All of your inputs are going to get grounded to this point. This is your 5 volt reference. This is a constant 5 volt output. Do not overload this because it can be overloaded. And then each one of these volts is going to be for you to be able to input your 5 volt off of your sensor for it to read. Now the aux ins, I'm guessing, this is to the best of my knowledge, that would be for like, hey, I'm going to put a switch in place so there is fuel maps on a switch, or whatever, rolling anti-lag or launch control or whatever. That's what the aux ones are for. So at some point those might get used on this car, but for right now they're not going to. So we're going to wire in the basically the green, the red, and then we will use the white and the blue are the wires that we will be using. Everything else will trim and terminate properly, and then make sure everything is a good soldered connection and get everything wired up so we can actually power up the ECU. It is 10:45 and we just literally 5 minutes ago got the unlock code for the ECU. So now we can at least push forward and try to get this thing started today. All right, guys, so it has been the better part of a week now. My tuner has been on vacation, and I'm happy to, I'm happy that he was out, able to take some time off. We did get the standalone figured out. The dilemma we were having is the computer would not connect to the car at all, and it would show up link ECU, but it would not actually pull up in the actual link program on my laptop. So we were having issues with that, fighting that, and we ended up having to switch the jumpers back from the WRX position to the STI position, and it worked perfectly the second we did that. So the car does run. It is on a very, 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 very basic tune, so it will just literally start up and pull onto a trailer. We've heat cycled the motor now. It does, it did everything it's supposed to. It idles, it keeps at temperature, and it does not have any issues with things leaking or anything like that, which is a huge plus. And that's just something we've been trying to really focus towards, is making sure when we get these builds done, they're ready to go from the get-go. So I'll throw the tripod out here and we will start this thing up for you guys, and you guys can see this car has 0 tuning done to it right now, and it just starts up so beautifully, and I really am happy about that. So Alright guys, so we are finally back up here at Nemtech. We got the Rocketwagon for the most part ready to go, and we are going for a 1,000-mile 91 boost tune. And basically we're just doing that because that is what's going to follow our break-in guidelines. At 3,000 miles we'll come back with full synthetic in the tank, or in the oil pan I should say, and we will go for a full E85 tune. But yeah, basically we are going to be seeing what this thing will do. So if you guys stuck around to this point, here you go. Here's going to be some fun dyno content for you. Get some good shots and hopefully see some cool stuff. So basically where we're at with this thing right now is we've done 2 pulls at this point. We had a little bit of an issue with our link cable that is for the actual USB that plugs into the ECU. Just a little bit of a short, we'll replace that, no big deal. Car on the second pull on wastegate with no timing stuck into it yet, made 301 wheel horsepower, so we're pretty pumped on that. Alright guys, I can't thank you guys enough for watching. The car ended up making 402 wheel horsepower, pump 91, E0, and for being a long rod motor, that is absolutely ripping. So we got a few more miles to put on this thing before we can go to full synthetic, and then we will be going back for an E85 tune, and I will make sure to make a nice long video on that. Thanks for watching guys. Hopefully you learned something. Stick around for the next one because there is more coming.